webcam school appropriate at all times. And know that your participation and engagement is dearly appreciated. And as always, Class Connect sessions will be recorded and distributed for learning purposes. Today is our last notes of the class and the last notes of Unit 5. We're going to be talking about circuits. We have eight days left in this trimester, which is kind of crazy. Do notice that we do have an exam for Unit 5, but it's going to be given in class on starting tomorrow and finished on Friday. Okay, it's not like notes where I'm going to give you the answers, but it's going to be like an open note test where I have the slides available for you to look at as you answer your questions. Okay. Also, I'm going to zero out our grade book with the exception of the Unit 5 exam. So you will know exactly where you are and what you need to do before the trimester. Samantha, no, you're good. You're here now. That's the important thing. So no worries. Okay, give me a thumbs up. Let me know that you have the notes and you are ready to go. Thank you, Cooper. I appreciate you. Thank you, Gwen. Thank you, Diego. Thank you, Tito. Thank you, Layla, Mimi, Roro, and Samantha. You guys are amazeballs. Thank you, thank you, thank you. Okay, so are there videos to help for the Unit 5 exam? Yeah, I'll record it as we do it, and then I'll release it that day also. Yep. But yeah. Yep. It's going to be very, very similar. Well, I'll show you tomorrow. Okay. But it shouldn't be hard for you. I really don't think it'll be hard for you. And I'm going to be there too, so that if you want to check answers with me as we take it, we can do that as well, just like we do in class. Okay. Okay. So today we're going to talk more about series and parallel circuits, and then we're going to be able to calculate the total resistance in a series circuit. Okay. So tell me, that image on the left on the screen, how many pathways are there in that diagram? Okay. Yep. Cooper. Yep. Okay. Some other people, tell me, how many pathways do you see? Layla, exactly right. Yeah. The left side. Yes. Awesome. Thank you, Cooper, Layla, Mimi, Gwen, Samantha, Tito, and Haley. There are 3 pathways. And Cooper, yeah, it's a parallel, right? Because it's multiple pathways. On the right side, okay, on the right side, how many pathways are there in that example? Yeah, exactly. Only one, right? Only one. And with only one, it is a series. Exactly right. So that's questions 2 and 3. Okay. So you can see the blue pen actually draws the pathways that the electrons can go, right? So we're going to do a lot of this today. Okay. You're going to get bored out of your skull as you are drawing these or looking at these. Awesome. Awesome. Thank you for clicking on the activation button up there when you are done. I appreciate that. Thank you, Ala and Cooper, Gwen, Haley. Thank you, Tito, Leandra, Layla, Mimi, Roro. Thank you, thank you, thank you. Awesome. Fabulous. Okay. Giovanni, Jeremiah, Samantha, you good? Okay. Christian and Destiny. Edwin, you guys good? Yeah. Okay. So when we look at an incandescent light, okay, now LEDs are a little bit different, but an incandescent light, okay, we notice that the electricity, when it comes into the light, there is a wire, right, that comes up, okay, and then there's a filament, and this filament is a thin piece of wire that the electrons flow through, and that wire, the filament, is lights up and burns brightly, and that's what is giving us our light. Okay, and then the electrons exit with a different wire out, and then they go wherever it's going. Okay, so that's a filament in an incandescent light. Now, when the filament is burnt out, okay, that circuit is broken and the circuit becomes an open circuit. Okay, so when the light bulb has its filament, it works. When it's broken, it doesn't work anymore. Okay, so Christmas tree lights. Okay, tell me, is this one pathway or multiple pathways? Tell me in the chat box. Yeah. Okay, look at that yellow dotted line, right? Okay, there's only one way for the electrons to go. So does that make it a series or does that make it parallel? Hey, Riri, I'm glad you're here now. Yeah, Mimi and Layla, yes, it is a series, right? Exactly. Okay. In a series, what happens if one of the light bulbs burn out? Cooper's got it. What happens to all the other light bulbs? All the other light bulbs turn off. Yeah, exactly. Exactly. Good job. Okay. So that's the answer to question number 4. When one pathway, when we have a series circuit, if one light bulb is broken, all of them are. Has anybody taken Christmas tree lights, excuse me, and looked for that broken one, right? Has anybody done that? Yeah. It's a pain, right? Big pain. And I have to admit, I am not very good at it. I can never find the broken light. It's always one of my kids or one of my husband. Not one of my husbands. I only have one husband. But yeah. Okay, now look at this one. Okay, is this multiple pathways or is it a single pathway? Okay, yeah, this one has multiple, right? Exactly. And if I were to count them, it would actually have 10 different pathways that the electrons could go. Okay, with this one, if one light bulb goes out, what happens to the other light bulbs? Tito, yeah. Yep. The others are going to stay on. Exactly right. Yeah. because those electrons can travel to each one of those light bulbs, right? Yeah, just because one of the pathways is broken doesn't prevent the electrons from getting to the other light bulbs that work. Exactly. Thank you, thank you, thank you. Thank you, Cooper. Thank you, Donovan. Hey. Thank you, Gwen. Thank you, Haley and Tito, Leandra, Layla, Riri, Ro, and Samantha. Thank you, thank you, thank you. I appreciate you guys. Awesome. Perfect. Okay, now, how many pathways are here? Tell me, count them. How many pathways are there? Yep. Donovan, good job. Yeah, yeah. There are 4 pathways, right? Yeah. Now, what happens if one of the light bulbs in that top row go out? Okay. What's going to happen to the pathways number 1, 2, and 3 are going to do what? And the top row, as Cooper says, the top row turns off. So what's row or pathway 1, 2, and 3? Are they the others are going to be fine? Yeah, exactly. Exactly. Yeah. So for this question, there's 3 correct answers, right? Okay. Yep. So in that in the pathway with the broken light, those lights will turn off, but the other pathways are going to stay on and will be fine. Exactly right. Party. Thank you, Cooper. Thank you, Donovan. Thank you, Haley. Thank you, Tito. Thank you, Layla. Thank you, Mimi, Riri, Ro, and Samantha. Thank you. Thank you, Glenn. Fabulous. Awesome. Okay, now there is another type of incandescent light with a little bit of a trick, and this is called a shunt wire. Okay, a shunt wire, right, actually has a second thin wire underneath the filament. Okay, and so how many pathways are there in this single light bulb now? If there's a little bitty wire underneath the filament, how many pathways are there in that light bulb? Yeah, 2. Exactly. Good job. So proud of you guys. Yeah, there's 2. And so now, if the filament breaks out, does the circuit break? Good. Yeah. Thank you, Tito. Yeah. Now, even if the filament breaks, okay, the shunt wire can still pass those electrons through. So the circuit stays closed. It's just that single light bulb that goes out. So yeah, that's sort of a get around, right? Of having incandescent lights. Okay. They cost a little bit more, but they're not as maddening. Thank you, Alla. Thank you, Cooper. Thank you, Gwen. Thank you, Haley and Jeremiah, Tita, Leandra, Layla, Mimi, Riri, and Samantha. Thank you, guys. I appreciate you guys. Okay. Oh. Now, when we're talking about circuits, okay, three things we need to think about, okay? Current, that's the electrons flowing through the wire, right? We have resistance, okay? And resistance is how hard it is for the electrons to move through the wire, okay? And that's going to be determined, yeah. Is a toaster bad to heat up bread because of the wires? No, no. That's how toasters work, right? Yeah. It's just changing that electrical energy into a thermal energy, right? So it's a transference of energy. Yeah, absolutely. Okay, so resistance, back to resistance. Resistance is how hard it is for those electrons to get through a circuit. And remember that light bulbs, toasters, hair dryers, anything that uses electricity, the energy from electricity to make a different type of energy, those are resistors, right? And the more resistors there are, the more resistance there will be, okay? And then the last thing that we need to remember is the potential difference. And the potential difference is the electrical energy, the difference between the electrical energy at the positive part of the battery compared to the point right before it enters the negative side of the battery. So that difference is measured in volts, okay? So when we think about this, okay, what's happening is you've got the current. Hey, Maddie, so glad you could be here. The current is flowing through the wire. The volt, right, is the potential difference from the battery that's pushing those electrons through the wire. And then we have our resistance. And resistance is measured in ohms, okay? And that is represented by the omega sign, which is a Greek letter, okay? So that is kind of what's happening in the wire, as if you think of it as little people. You could also think of it as if you were in a school building, right? And the bell rang at the end of the day, and all the students were trying to get out of the building, right? Each door, okay, is like a resistor, right? And the more doors that there are, and the more doors that are closed, the harder it's going to be for the students to open the doors and get out of the building. It's just adding a layer of something else to do to get through, to get to the outside, okay? So with that, we can calculate the total resistance in a circuit. Now, in this class, we're only going to calculate the resistance, the total resistance in a series. We're not going to do it in a parallel circuit, just because it's a little bit more complicated and we've run out of time. But do remember, resistance is measured in ohms, okay? OHMS, okay? So the formula for total resistance is you just add up or sum the individual resistors, okay? So we have to add numbers together, okay? And this is question number 8. Let me know when you are finished with question number 8. Thank you, Roro. Thank you, Leandra and Tito, Jeremiah, Gwen, Layla. Thank you, Donovan, Cooper, Alla. Thank you, thank you, thank you. You guys are amazing. Thank you, Giovanni. Fabulous. Okay, so here we go. Okay. I have a circuit here. You can see it's a series circuit, right? There's only one path going around. These squiggles right here represent a resistor. So this is resistor 1, this is resistor 2, and this is resistor 3. You can see that the formula, right, is just adding the resistors together, right? So resistor 1 is 5 ohms, okay? So 5 plus 7 plus 3, okay? And you can see where I got these numbers right there from the schematic, right? So 7 plus 3 is 10, plus 5 makes 15 ohms, okay? So that's the answer to number 9, 15 ohms. Make sure you spell ohms right, by the way. Okay. Thank you, Cooper. Thank you, Gwen and Haley, Tito, Leandra, Layla. Thank you, thank you, thank you. Thank you. Thank you, Riri. Thank you, Mimi and Samantha. Awesome. How did I get your numbers? Like, oh, so Cooper, did you see where I got my numbers? Yay or nay? Yeah, kind of. Okay, let's do the next one and it'll be pretty simple. You'll see. Yeah. Basically, yeah. Okay. So here's another series circuit, okay? Again, remember that a resistor is going to be represented by the squiggle in the diagram, okay? So why is this? There it goes. My Wacom just died. Weird. Okay, so here is 3.1, right? And this is going to be resistor 1. Because it doesn't matter when I add things up, the order or the sequence, I could call this resistor 4 if I wanted to. But resistor 2, yes, yes, yes. Resistor 2 is going to be 4.2. Resistor 3, wow. A resistor 3 is 8 or 6.5, and then resistor 4 is 7.4 ohms. Notice that my formula has an ellipsis right here, and that just means you just keep adding all the resistors. So if I had 20 resistors, I would just add all of their resistors together to get that. So now I just have to add 3.1, and I apologize how messy this is. 4.2, okay. In fact, I'm just going to close this and go to the next one since my thing is broken. There you go. Okay. No, I have a pad and a pen. I don't know. Can you see this? That I normally use to help write things on, and it quit working. So I was trying to freehand it, and that was horrible. Yeah. Okay. Thank you, guys. When you are finished with question number 9, click on that activation tag for me. Thank you, Samantha. Thank you, Roro. Thank you, Riri. Thank you, Layla, Leandra, Tito, Haley, Gwen. Thank you, Ala, Cooper, Diego, and Donovan. Awesome. Aw, love the purple hearts. Okay, last question. Okay, last question. Thank goodness, right? So Cooper, no. Do it again. Add those again. Okay. Um, if you want to check your answer, you are more than welcome to private message me. Okay. Yes, Gwen. Yep. Tito, yes. Yep. Haley, you got it. Perfect. Okay. Layla, yes. Leandra, absolutely. Ala, yep. Okay. Awesome. Thank you, Gwen. Thank you, Jeremiah and Tito, Leandra, Layla, Samantha. Thank you. Thank you, Cooper. So, Mimi, on question 11, it's complete on your own. Okay. Leandra. Yay. Yeah, I think we are done. I think we are done. So, how you feeling? Last notes. Woohoo. Right? Party, party, party. If you are feeling good, you are more than welcome. Okay. Mimi, if you need to hang with me. Okay. Roro, you can also hang with me. Okay. Awesome. Otherwise, I hope you have a wonderful, wonderful day. Oh, thank you, Cooper. Roro, did you see Cooper's gotcha? Bye. Have a fabulous day. Thank you, Leandra. Have a great day, Tito. Bye, Gwen. Bye, Haley. You too. Bye, Leandra.